Okay, good morning. First of all, thank you for the invitation, the possibility to present here my, let's say, smaller research project here. Okay, thank you. The name is Membrane Data Parametrics, and actually this is the fourth presentation of this project here at this very university. It started as a student research in 2011, and it is an ongoing project, and let's get to the introduction. First, I'm Bálint Füzes. I graduated as an architect here around 3 months ago, and my professor is Dr. Dezső, Hegyi, associated professor again from this university, from the Department of Mechanics, Materials and Structures. And as I said, we started in 2011, and our topic is the parametric details of membrane constructions. For those who are not very familiar with this type of structure, because I experienced that even architects are not really, so even for architects it's not really known, this type of load-bearing structure. Membranes are mostly used as stadium roof covers of public areas, and shading systems. And you can see some examples here. I actually had the luck to work at this company in Germany who built the Allianz Arena in Munich. And so as you can see, membranes are technically foils, and they're gaining more and more investment due to the developments in the fabric industry, and they are used at more and more constructions. And they have some very, very strong characteristics. For example, that they have an almost negligible dead load. So it is very unique compared to the span that they can cover. That they're very, very, very light constructions. And the other main point of them is that there is only tension in the surface. And the third very important characteristic of this type of structure is that the details are very complicated to model, to design, and they come up in very large numbers, and they can have small differences regarding the length and the angles. So this can be a very time-consuming task if you have, for example, a roof cover for an airport where you have 30 or more examples of such a complicated detail. And actually this is why this project has actually two goals. First goal was even at the start to create a compilation of this knowledge. The details of the membranes, they are very, very strongly related to the stability of the structure, because there are actually these are the weakest points of the surface where you have the tensioning elements. And on the other hand, the degree of freedom of the elements, it is very, very important for the entire stability of the structure, and that the surface is not folding when you build in some wrong detail. And this very important topic was not combined together in some kind of a database. There was no focused collection before this project actually. So that's why we made this internet library for everyone to freely browse through and to check out these details. And so this was the first goal, and the next goal is this current stage, to parameterize these details. So again, back to the first stage when we made the website. At membranedetail.com you will find plenty of examples of these kinds of details. Of course, at the very start I only made 2D simple drawings, and only for corner details. Even corner details have lots and lots of alternatives. And we based the whole study on the mechanical behavior of the entire of the unique elements. So you have main groups, and you can find it all there on the website. And of course, at the next stage we went 3D, and again, if you go to the website, you will find examples to technically any kind of building construction or situation for membranes. This is a corner here with a surface connection in the midst, and you will find anchorages, masts, corners, surface connections of all kinds on the website. So this is really, it really gives you an extended look how membranes can be built regarding the very tensioning structures, the details. Again, corner details, anchorages for suspended rods, and all of that. So this is all free to browse through for engineers or students to get an extended look of how these work actually. And of course, this stage now currently is to somehow make this compilation of this huge amount of details flexible and useful for engineers, because if we go back here, I made around 100 AutoCAD details, and I rendered them and I put them on the website, and now we would like to give an up-to-date usability to the system. Yeah, because if in case this project is actually aimed maybe a bit, it may sound a little bit strange, but this is mainly aimed at companies that do not exclusively focus on membranes. Because if you are a bigger membrane company, you will definitely buy a bigger software, but even big softwares are mainly focusing on the form finding of the surface, which means you will have an export-import demand between these monstrous softwares. And we would like to avoid that, so this, let's say, smaller plugin can be combined with Rhino Grasshopper, which is more often used and can be connected to day-to-day tasks for engineering companies. And now these details, they're very similar to that I showed you earlier, but now they are flexible details and can be integrated into projects. I will get back to them, but first about this small, let's say, beta system I developed. This is actually based on the simultaneous functionality of two files. There's of course a background component file with the models, and there is the algorithm. And this is actually the easiest way to spread this system through the internet for those who would like to use it. And since you only need these two files to get it activated. And these are the elements, typical membrane elements, profiles, anchorage plates, tensioning elements. These come up in large numbers. These get orientated in the modeling space. And this is a point here that actually real products could be modeled here. And that's why this tool could be even a tool for manufacturing companies to trade their products digitally, of course. Yes, and the algorithm is very ugly, and it is different in each case for each algorithm. But the point is that you, as a customer, are going to only see this one. So you only will see a very, very neatly ordered menu of how you can activate your algorithm, how you can accelerate your engineering work, and how you can spare time with this quite complicated 3D models. So this is actually aimed at users that are completely inexperienced in coding. And of course the main steps are very easy. You have to just simply put your axis curve onto a definite layer. Everything gets activated. You have to just simply choose from these parameters, choose the head of the cable, choose the number of the anchorage plate and all. So this can get very, very, very fast and very, yes. Yeah, actually there is always a starting geometry, like the axis curves. If you have, for example, this situation, you will have 3 axis curves meeting in one node, and the actual detail is generated around it, and it realigns itself if you pull the node aside or something. And then you can choose from the separate options for the details, and then you see these differences, how it aligns itself, and yeah, I think it can really spare time on company level. these are the algorithms I made actually as a proof that this tool can be quite a robust one, and that it can really be useful for the most common situations of membranes, corners, flexible corners, and wires, and of course even bigger masts. Yeah, these are it. And now at this point, the difference between the separate details is only one click and not a 4-hour long modeling session. Yes, a mesh detail also quite complicated, but this can all algorithmize. Yeah, I cannot really go into the detail now how the coding behind it is built up, because it's really long, and even the main problematic cannot be set here. But actually, the grouping, the partitioning of the data, it is the main issue here. How you put all this data into separate groups that they give back a valid result for you. And of course, there is a background for this massive algorithm, mainly actually letting the two files function simultaneously and importing the elements and orienting them in the modeling space. And of course, you can have a bill of quantities in Excel at the end. And yes, actually, I am quite optimistic that this is worth investing in regarding the time and all, because I get already let's say a buyer for a smaller algorithm for 4-point membrane. This is actually a wastewater treatment company. They build wastewater treatment plants all around the world, and they use plants to clarify the sludge water, and they need membranes all over it to shade the plants, and this is why they ordered a smaller algorithm, because membranes is a day-to-day task for them. And of course, this algorithm can go in other directions, but the best would be to simply connect it with CAADence now that there is a correct connection between them. And of course, I will make the website now new in the next couple of months and upload some details there to download it and to spread it to companies. Yes, and yes, I think I mentioned everything that was important in this beta stage of the project. So thank you for your attention.